welcome to Unit 5, where in this unit we're going to talk about lots of different applications of derivatives. In this first lesson we're going to talk about curve sketching. Now, you might remember back in probably secondary math 3, when you may have graphed things like this. And maybe you asked your teacher, how do I know how far down this curve goes? And your teacher probably said, well, we don't, until now. We're going to do some curve sketching, but to a whole new level, where we are going to use derivatives and second derivative to sketch a really detailed curve. So you have your curve sketching recipe right here. I'm going to go through those steps in this first example. Okay? Now, first off right here, thankfully in this example, we don't have to find the derivatives. They're found for us, which is nice. Usually you would need to go through and do quotient rule on this to find the first and second derivative. So what we're going to do, start step 1, give the domain. Domain is basically going to always be all reals except for any asymptotes that we have. So asymptotes is the denominator. That's what makes the graph undefined. So if I look at this denominator really quickly, set this equal to 0 to find my asymptotes, I quickly notice that I'm taking the square root of a negative number. We can't do that. That's imaginary. That's complex. So that means we do not have any vertical asymptotes for this problem. So in this case, the domain is all real numbers, or negative infinity to infinity, because there's no asymptotes. Next, let's see if we have any holes. Remember, holes are where things cancel on top and bottom. I don't have anything that crosses out on top and bottom, so I don't have any holes for this one. We also said no vertical asymptotes because there's nothing that makes the bottom undefined. Let's talk X-Intercepts. That's where the numerator is set equal to 0. So we're going to get x cubed equals 0. Cube root that. Cube root of 0 is 0. So our X-intercept is just 0, which we always write as a coordinate pair. And we're going to graph that right there. There's our x-intercept. Y-intercept, so this is x-intercept is where the numerator is equal to 0. Vertical asymptote is where the denominator equals 0. Holes is when things cancel. Y-intercept is when your x's are 0. So I'm going to set all my x's to 0. So I get 0 over 1, which is 0, which I also write as a point. Ta-da! End behavior is where I ignore all the things that don't really matter, because this is as we're going to infinity. So infinity, that plus 1 doesn't really matter. So I've got an end behavior of 2x cubed over x squared, which is going to simplify to 2x. Now, if I think of the graph of 2x, that's a linear that goes up, a positive linear. So that means my end behavior as I go to infinity to the right is going to be, as I go to the right, up to infinity. And my end behavior as I go to the left is going to be down to negative infinity. Let's color code all of these so it's easier to see. So this is as I go to the right, it goes up to infinity, and as I go to the left, it goes down to negative infinity. That's my end behavior. And I always like to graph end behavior as circles. So as I go to the right, we're going to go up to infinity, that's why I put my circle there. As I go to the left, we're going to go down to negative infinity, and that's why I put my circle there. That kind of tells me where the ends of my graph should point, the end behavior. Okay, now, technically, everything we've done up to this point is secondary math 3 stuff. We're just now getting into the calculus stuff. So for the calculus stuff, we are going to create number lines, sign lines, for our original, our first derivative, and our second derivative. Now, if you remember, the things that go on sign lines are critical numbers. So I'm going to find my f critical numbers, my f prime critical numbers, and my f double prime critical numbers. And critical numbers are essentially shortcut where the numerator is 0 and the denominator is 0. Those are your critical numbers. So if I look at my original f, set my numerator equal to 0 and solve that out, I'm going to get a critical number at 0. So I add that into my sign line. Set the denominator equal to 0. This should look kind of familiar. We know that's going to be undefined. It's going to be imaginary. So for my f, 0 is my only critical number. And now I can start to plug things in. So let's plug something in from the left. So negative 1 into f. 2 times negative 1 cubed is a negative 2. So that's going to be a negative on top. And negative 1 squared is a positive 1 plus 1 is a positive on bottom. And a negative divided by a positive is going to be a negative in that section. And plug in a positive number, say positive 1. 2 times 1 cubed is positive. 1 squared plus 1 is positive. So that section should be positive. Now, we know from what we talked about last chapter that this critical number is an intercept. Check. That's going to be an intercept. Positive means the top half. So left of my intercept, right of my intercept, I'm going to box the top half. That means negative means the bottom half. So left of my intercept, I'm going to box the bottom half. And that's where my graph should be. Now let's talk about f prime. So f prime critical numbers. So first I have the numerator. And I solve this out, I get a critical number of 0 again. And if I solve this one out, minus 3, I'm going to quickly see that I'm going to take the square root of a negative, so that one's not going to work. And where the denominator equals 0, we also know that one's not going to work. So once again, 0 is my only critical number. So let's plug in a number from the left, say negative 1. 2 times negative 1 squared is a positive, so that's in a positive. Negative 1 squared plus 3 is also a positive, so that means my numerator is going to be positive. And then I have negative 1 squared plus 1, and square that is a positive. So this is going to be a positive over a positive, which is going to be a positive. Just a minute, baby. Now let's take a number to the right. So let's say a positive 1. 2 times 1 squared, 1 squared plus 3. I plug all that in. 1 squared plus 1 squared. Also a positive over a positive. So also still positive. So that means that I'm going to have a critical number at 0, and remember that that is a possible max or min. Possible. That's what we learned last chapter. And that positive on this means increasing. Negative means decreasing. So we're going from increasing to increasing. So that means 0 is not a max or a min, because we're going from increasing to decreasing. We're not changing signs. So we're going to do something that's increasing and then still increasing. Okay, now let's do f double prime. Let's find my critical numbers first. So I have all these equal to 0. If you solve that out, we're going to get critical numbers at 0, at plus or minus square root of 3. And now I plug things into my sign line again. So I'm going to leave that up to you. Pick a number left of here, so say negative 4 or whatever. plug it into here, see if it's positive or negative. This section should be positive. Oh, I feel like I'm going to sneeze. Okay, pick a number from this section, plug it into our second derivative, because that's the line we're on, simplify it, and we should get a negative. Pick a number from this section, plug it in, simplify it, we should get a positive, and a number from our last section, plug it in, should get a negative. So this is our concavity. So this should be concave up, concave down, concave up, concave down. And remember what we talked about, that these points are our possible points of inflection. And it's only a point of inflection if it changes concavity, which this one is. So this changes from positive to negative, so that's going to be a point of inflection. Changes from negative to positive, so that's a point of inflection, and from positive to negative, so that's a point of inflection. So now I can go here, let's find negative root 3, which is going to be about here, and positive root 3, and figure out what these points of inflection are. So actually plugging them into the real function. So I'm going to play negative root 3 and positive root 3, plug them into here, and simplify to see what I get. And you should end up with these. Sorry, I'm not taking so much time. I know this video is already very long. That's why I'm not doing all the calculations. So I should have a point at right here, which is going to be a little more than negative 2, so there-ish. And right here, which is going to be a little more than positive 2, so there-ish. So I'm going to be concave up to this point. And notice I'm still increasing. Then I need to be concave down from here, but still increasing. Concave up between here, but still increasing. And then concave down here, but still increasing. And there's our graph. Now let's finish answering this. Do I have any maximum or minimum points on this? No, I do not, because f prime doesn't change signs. And that's it for the first example. We have 2 more to do.